Hello and welcome to my channel. I'm so glad you're here, settling in for another gentle journey through the cosmos. Tonight, we're going to witness one of nature's most breathtaking performances, the aurora borealis and aurora australis, those mysterious curtains of light that dance across polar skies like whispered secrets from space itself. Whether you've stumbled upon this video while winding down after a long day, curling up in bed with your favorite blanket, or simply seeking a peaceful moment of wonder, you've found the right place. This is where science gets soft-spoken and curiosity wraps itself in starlight. Now, I do hope this exploration isn't too captivating after all. The goal here is gentle relaxation. But if you find yourself still awake by the time we discover how solar particles waltz with Earth's magnetic field, well, at least you'll drift off with visions of cosmic ballet in your mind. Before we begin our luminous journey, I'd be ever so grateful if you gave this video a like and perhaps subscribed to join our community of sleepy scientists. It helps more peaceful souls find their way here, and it means I can keep creating these soft explorations of our magnificent universe. I'm curious, where in the world are you listening from tonight? Are you tucked away somewhere in the Arctic where you might actually glimpse the northern lights, or perhaps you're on the opposite side of the planet, dreaming of Antarctic auroras? Drop a comment and let me know what time it is in your corner of the world. There's something wonderfully soothing about knowing this little constellation of listeners is scattered across the globe, all sharing this quiet moment together. So settle back, close your eyes if you like, and let's embark on a gentle voyage to the edges of our atmosphere, where Earth's invisible shield creates one of the most beautiful light shows in the solar system. Picture this. You're standing on a frozen lake in northern Alaska, your breath forming small clouds in the crisp air. The temperature hovers around -20 degrees, and the night sky stretches endlessly above you, so clear and dark that the Milky Way looks like spilled sugar across velvet. You've been waiting patiently, perhaps for hours, scanning the northern horizon for any sign of movement. Then, almost imperceptibly at first, a faint green glow begins to emerge. It starts as just a whisper of light, barely distinguishable from the star-filled darkness. But slowly, gracefully, it begins to grow and shift. Vertical columns of emerald light start rising from the horizon like ethereal curtains being drawn across the sky. They shimmer and undulate, sometimes pulsing brighter, sometimes fading to the faintest suggestion of luminescence. This is the aurora borealis, the northern lights, one of Earth's most enchanting natural phenomena. And far to the south, above the icy expanses of Antarctica, its twin sister, the aurora australis, performs the same celestial dance for penguins and polar researchers alike. But what exactly are these dancing lights? Are they some kind of atmospheric weather, like clouds made of electricity? Are they reflections of something far away? Or perhaps they're caused by ice crystals high in the atmosphere, catching and scattering light in mysterious ways? The truth, as it often is in science, is far more elegant and intricate than fiction. Auroras are the visible manifestation of an invisible battle, a gentle, constant conflict between our Sun and Earth's protective magnetic field. They're the luminous evidence of particles that have travelled 93 million miles through the vacuum of space, only to be caught and guided by invisible lines of magnetic force into a spectacular light display. To understand auroras, we need to begin not with Earth, but with our Sunday. That blazing ball of nuclear fire that warms our days and lights our world is far from the stable, unchanging beacon it appears to be. The sun is restless, dynamic, constantly churning with activity that sends streams of charged particles racing outward in all directions. Imagine the sun's surface as a boiling cauldron of plasma matter so hot that electrons have been stripped away from their atoms, creating a sea of electrically charged particles. This plasma moves in complex patterns, driven by the sun's powerful magnetic field, which twists and writhes like invisible ribbons in the solar atmosphere. Sometimes, these magnetic field lines become so tangled and stressed that they snap, releasing tremendous amounts of energy in events called solar flares. Other times, massive bubbles of plasma break free from the sun's surface in what scientists call coronal mass ejections. And always, continuously, there's a steady stream of particles flowing away from the sun in all directions, the solar wind. This solar wind isn't like the gentle breeze that rustles leaves on an autumn afternoon. It's a hurricane of charged particles, mainly protons and electrons, racing through space at speeds of several hundred kilometers per second. From the sun's perspective, it's breathing out this constant stream of particles, exhaling the very substance of its being into the cosmic void. Now you might wonder, if the sun is constantly blowing this stream of particles toward Earth, why aren't we all fried by solar radiation? Why don't these charged particles simply slam into our atmosphere and make life impossible? The answer lies in one of Earth's most important, yet invisible features, our planetary magnetic field. Earth behaves like a giant magnet, with magnetic field lines stretching far out into space. This magnetic field isn't just an interesting scientific curiosity, it's our planet's shield, deflecting most of the solar wind around us like water flowing around a stone in a stream. Without this magnetic protection, our atmosphere would gradually be stripped away by the solar wind, just as Mars likely lost much of its atmosphere billions of years ago. But Earth's magnetic field isn't perfectly spherical. It's compressed on the day side by the solar wind and stretched out into a long tail on the night side, creating a teardrop-shaped region called the magnetosphere. This invisible magnetic bubble extends far beyond our atmosphere, creating a protective cavity in which our planet safely orbits. The boundary where the solar wind first encounters Earth's magnetic field is called the bow shock. Imagine the V-shaped wake that forms at the front of a boat moving through water. Here, the supersonic solar wind suddenly slows down and heats up as it encounters the immovable obstacle of Earth's magnetic field. Most of the solar wind particles are deflected around the magnetosphere, streaming past Earth and continuing their journey into the outer solar system. But some particles find their way inside. They slip through cracks and gaps in our magnetic shield, particularly near the magnetic poles where the field lines converge and dive down toward the planet's surface. These particles become trapped in Earth's magnetic field, bouncing back and forth between the north and south magnetic poles like beads sliding along invisible wires. They form regions called the Van Allen radiation belts, donut-shaped zones of charged particles surrounding our planet. But the story doesn't end there. When conditions are just right, when the solar wind is particularly strong, or when Earth's magnetic field is disturbed by solar activity, some of these trapped particles are accelerated downward along the magnetic field lines toward the poles. They plunge into the upper atmosphere at altitudes of roughly 80 to 500 kilometers above the surface. And this is where the magic happens. These high-energy particles collide with atoms and molecules in our atmosphere, primarily oxygen and nitrogen. The collision transfers energy to these atmospheric particles, exciting their electrons to higher energy levels. But electrons don't like to stay in these excited states for long. They quickly fall back to their normal energy levels, releasing the excess energy as light. Different atmospheric gases produce different colors when excited. Oxygen creates the most common aurora color, that ethereal green that appears in so many photographs of the northern lights. At higher altitudes, where the atmosphere is thinner, oxygen can produce red light. Nitrogen contributes blue and purple hues, while sometimes rare interactions can create pink or yellow auroras. The result is a light show that occurs roughly 100 kilometers above your head, higher than any airplane flies, higher than most satellites orbit, in that thin realm where space begins to blend with atmosphere. The aurora exists in this twilight zone between Earth and space, a luminous bridge between our world and the cosmos. But auroras aren't just random splashes of color across the sky. They follow the invisible architecture of Earth's magnetic field, creating patterns that mirror the magnetic field lines themselves. This is why auroras typically appear as curtains or bands of light, They're literally illuminating the shape of our planet's magnetic field as it funnels solar particles toward the poles. The aurora oval, the ring-shaped region around each magnetic pole where auroras most commonly appear, expands and contracts based on solar activity. During periods of intense solar weather, the aurora can be seen much farther from the poles than usual. Residents of northern Scotland, Canada, and Alaska might see the northern lights dancing overhead, while those in southern Tasmania or New Zealand might glimpse the southern lights on the horizon. These displays can last for minutes or hours, sometimes pulsing and flickering like a cosmic heartbeat, other times flowing across the sky like luminous rivers. Some auroras appear as discrete rays shooting up from the horizon, while others spread across the entire sky in sheets of undulating light. No two auroral displays are exactly the same. Each is a unique interaction between our sun, our magnetic field, and our atmosphere. The intensity and frequency of auroras follow the sun's 11-year cycle of activity. During solar maximum, when the sun is most active and producing frequent flares and coronal mass ejections, auroras become more common and can be seen at lower latitudes. During solar minimum, they retreat toward the poles and become more subdued. There's something deeply poetic about the fact that these lights in our sky are essentially the sun singing to us across the void of space. Every aurora is a message written in light, telling us about conditions on our nearest star and the invisible forces that protect our planet. The dancing curtains of green and red are love letters from 93 million miles away, delivered by particles that began their journey in the nuclear furnace of the sun and ended it as beauty in our night sky. Indigenous peoples around the world have known and revered the aurora for thousands of years, long before science could explain their origin. The Inuit believed they were the spirits of the dead playing a ball game with a walrus skull. Norse mythology described them as reflections from the shields and armour of the Valkyries. Finnish folklore claimed they were caused by the firefox running so fast across the snow that its tail brushed up sparks into the sky. These ancient stories capture something that science sometimes misses in its precise explanations, the sense of wonder and mystery that auroras inspire. Even now, when we understand the physics behind these lights, they retain their power to make us pause and marvel at our place in the universe. And perhaps that's as it should be. After all, we are witnessing something truly extraordinary, the visible evidence of our planet's magnetic shield, the light show created by our sun's breath, the dance of particles that have travelled farther than any human will likely ever go, all coming together in a display of natural artistry that has been painting the polar skies for billions of years. As you drift towards sleep tonight, imagine those curtains of light swaying gently above the Arctic ice, their green glow reflected in the still waters of mountain lakes, their ethereal dance witnessed by caribou and polar bears, by Inuit hunters and curious scientists alike. Picture the electrons falling back to their ground states, each one releasing a tiny photon of light that joins billions of others to create those luminous veils across the darkness. The aurora is always there, somewhere on our planet, a constant reminder that Earth is not alone in space, but is connected to the sun and the solar system by invisible threads of magnetism and streams of particles. Even when we can't see them, the northern and southern lights continue their ancient dance, a gentle celebration of the forces that keep our world safe and habitable. The relationship between the sun and Earth is far more intimate and dynamic than most of us realize. While we often think of the 93 million miles between us as empty space, it's actually filled with this invisible river of solar wind, carrying with it the magnetic personality of our star. And just as a river changes with the seasons, the solar wind has its own rhythms and moods that directly influence the aurora displays we see. Sometimes the sun is quiet, releasing only a gentle, steady breeze of particles. During these calm periods, the aurora retreats to a narrow band around the magnetic poles, visible mainly to those hardy enough to venture into the Arctic or Antarctic wilderness. The lights during these times are often subtle, perhaps just a faint green glow on the northern horizon, or delicate curtains that shimmer and fade like distant lightning. But the sun is not always so peaceful. Our nearest star has a complex magnetic personality, with field lines that stretch and twist and sometimes snap with tremendous violence. When this happens, the results can be spectacular. Solar flares burst from the sun's surface with the energy of billions of atomic bombs, hurling charged particles into space at incredible speeds. These solar storms race across the solar system like invisible tsunamis, carrying with them the potential for extraordinary auroral displays. When one of these solar storms reaches Earth, typically 2 to 4 days after leaving the Sun, it strikes our magnetosphere like a cosmic gong. The impact can compress our magnetic field, allowing more particles to slip through our defenses. The aurora oval swells, expanding far beyond its usual boundaries. Suddenly, people in places like New York, London, or even southern Spain might step outside to find the sky painted with colours they've never seen before. These magnetic storms don't just create beautiful lights, they remind us how interconnected our planet is with the rest of the solar system. The same events that paint our skies with aurora can disrupt satellite communications, interfere with GPS systems, and even cause power outages. In 1989, a particularly strong magnetic storm knocked out power to 6 million people in Quebec, Canada. The aurora that night was visible as far south as the Caribbean, but it came with a price, a reminder that we live within the sphere of influence of our restless star. The science of predicting these space weather events has become increasingly important as our technological civilization becomes more dependent on satellites and electronic systems. Scientists monitor the sun constantly, watching for signs of impending solar storms. They track the speed and intensity of the solar wind, measure the strength and direction of its magnetic field, and try to forecast when Earth's magnetosphere might be in for a particularly vigorous encounter. There's something almost meteorological about it all. Space weather forecasters issuing aurora alerts just as their terrestrial counterparts might warn of approaching thunderstorms. But instead of tracking clouds and pressure systems, they're monitoring magnetic field fluctuations and particle densities in the solar wind, trying to predict when and where the next great light show might unfold. The particles that create the aurora don't all arrive at once, nor do they all have the same energy. Some are moving relatively slowly, taking their time as they spiral down the magnetic field lines toward Earth's atmosphere. Others are racing at tremendous speeds, carrying enough energy to penetrate deep into the atmosphere before finally colliding with air molecules. This difference in particle energy is part of what creates the complex layered structure of aurora displays. The green light that characterizes most auroras occurs when particles strike oxygen atoms at altitudes of about 100 to 300 kilometers above Earth's surface. This is the most common aurora color because oxygen is abundant at these altitudes, and the collision energies are just right to produce that characteristic emerald glow. It's the same green that appears in certain streetlights, created by the same physics but under very different circumstances. Higher up, where the atmosphere becomes even thinner, oxygen atoms can produce red light instead. These high-altitude red auroras are less common but can be spectacular when they do occur, creating what looks like a crimson crown above the more familiar green curtains. The red comes from a different transition in the oxygen atom, one that requires more time to occur and is more likely to happen where atmospheric collisions are infrequent. Nitrogen, the most abundant gas in our atmosphere, contributes its own palette to the auroral spectrum. When struck by solar particles, nitrogen can produce blue and purple light, often appearing at the lower edges of aurora displays where the atmosphere is dense enough for these collisions to occur frequently. Sometimes nitrogen creates a pink or magenta color that can make the entire sky look like it's been painted with watercolors. Occasionally, very rare colors appear in the aurora, yellows and oranges that result from complex combinations of different gases being excited simultaneously. These unusual hues are like astronomical footnotes, brief glimpses of the full complexity of the processes happening far above our heads. Experienced aurora watchers treasure these moments, understanding that they're witnessing something that might not be seen again for months or years. The shapes that auroras take are as varied as their colours, each one reflecting the invisible architecture of Earth's magnetic field in that particular region. The classic curtain-like appearance happens when particles follow magnetic field lines that are roughly parallel to each other, creating those vertical columns of light that seem to hang from the sky like luminous drapes. But magnetic field lines aren't always so orderly. Sometimes they twist and curve, creating spiral or corkscrew patterns in the aurora. Other times they converge toward a point, producing what's called a corona, not to be confused with the sun's corona, where rays of light seem to radiate outward from directly overhead, as if you're looking up through the center of a cosmic flower. Pulsating auroras flicker on and off with a rhythm that can be almost hypnotic. These occur when the stream of particles arriving from space varies in intensity, perhaps due to changes in the solar wind or fluctuations in Earth's magnetic field. The result is an aurora that breathes with light, brightening and fading in cycles that can last for seconds or minutes. Some of the most dramatic auroral forms are called substorms, sudden, explosive, brightening events that can transform a quiet aurora into a dazzling display within minutes. During a substorm, what might have been a faint arc of green light suddenly erupts into brilliant curtains that dance rapidly across the sky, sometimes accompanied by the crackling sound of electrical activity in the atmosphere above. The sound of the aurora is itself a mystery that scientists are still working to understand. Many observers report hearing crackling, hissing, or whooshing sounds that seem to accompany bright auroral displays. For years, scientists were skeptical of these reports, reasoning that the aurora occurs far too high in the atmosphere for sound waves to reach the ground. But recent research suggests that the electromagnetic fields associated with the aurora might create sounds much closer to Earth's surface, perhaps through interactions with objects like hair, grass, or clothing. The timing of auroral displays follows patterns both predictable and chaotic. The 11-year solar cycle creates a rough framework: more auroras during the years of solar maximum, fewer during solar minimum. But within this broad pattern, aurora activity is tied to the 27-day rotation period of the Sunday. Coronal holes regions, where the sun's magnetic field lines stretch out into space rather than looping back to the surface, can create fast-moving streams of solar wind that sweep past Earth once every solar rotation, creating regular opportunities for auroral displays. Seasonal patterns also play a role. The aurora is most active around the equinoxes, spring and fall, when Earth's magnetic field is oriented in such a way that it can more easily connect with the sun's magnetic field carried by the solar wind. During these times, even relatively modest solar wind disturbances can produce significant auroral activity. But perhaps the most important factor is simply being in the right place at the right time. The aurora oval, that ring of activity around each magnetic pole, is constantly shifting. Sometimes it expands toward the equator, bringing the northern lights to places like Minnesota or Scotland. Other times it contracts, limiting aurora viewing to the high Arctic. The movement of this oval is controlled by the complex interaction between the solar wind and Earth's magnetosphere, a dance of invisible forces that determines who gets to see the lights on any given night. For those fortunate enough to witness a strong auroral display, the experience often transcends mere visual spectacle. There's something profound about standing beneath those shifting curtains of light, understanding that you're seeing the direct result of processes happening on the sun and in the space between worlds. The photons entering your eyes began their journey in nuclear reactions deep within our star, travelled across the solar system as invisible particles, and ended their journey as beauty in your night sky. The aurora connects us to scales of space and time that are difficult to grasp in our daily lives. The particles creating tonight's display might have been created in the sun's core hundreds of thousands of years ago, slowly working their way to the surface through the dense solar interior. Once released into the solar wind, they crossed the void between worlds in just a few days. And now they're ending their cosmic journey as light in Earth's atmosphere, their energy finally dissipated in service of one of nature's most beautiful phenomena. This celestial choreography plays out on a scale that's both intimate and cosmic. While we stand on Earth's surface, looking up at these dancing lights, we're actually witnessing events unfolding hundreds of kilometers above our heads. Yet the particles creating this display have traveled a distance so vast that light itself takes over 8 minutes to cover it. The journey of an auroral particle is like a cosmic relay race. It begins in the unimaginable heat and pressure of the sun's core, where hydrogen atoms fuse together to create helium, releasing tremendous amounts of energy in the process. This energy slowly works its way outward through the sun's interior, taking hundreds of thousands of years to reach the surface. Once it breaks free, it joins the solar wind and races across space at speeds that would carry it around Earth's equator in just a few minutes. When these particles finally encounter Earth's magnetic field, they don't simply crash into it like bugs hitting a windshield. Instead, they engage in a complex gravitational and electromagnetic dance. Some are deflected entirely, bouncing off our magnetic shield and continuing their journey into the outer solar system. Others become trapped, spiraling along magnetic field lines like cars following invisible highways in the sky. The most energetic particles penetrate deepest into our magnetosphere, sometimes reaching all the way down to the upper atmosphere, where they finally encounter something solid enough to stop them, the thin air molecules floating in that twilight realm between Earth and space. And when they do collide, they transfer their energy in the form of light, creating those ethereal curtains that have captivated humans for millennia. But the aurora isn't just a passive light show, it's an active participant in Earth's electromagnetic environment, creating electrical currents that flow through the upper atmosphere. These auroral electrojets, as scientists call them, can carry millions of amperes of current, more electricity than flows through the power lines of entire cities. Yet this current flows silently through the thin air 100 kilometers above our heads, visible only as shimmering light. The interaction between the solar wind and Earth's magnetic field creates a constantly shifting battlefield of invisible forces. During quiet periods, when the sun is relatively calm, the aurora retreats to its usual haunts near the magnetic poles. The lights during these times might be subtle, perhaps just a faint green arch low on the horizon, or gentle rays that flicker briefly before fading back into darkness. But when the sun becomes restless, everything changes. Solar flares can accelerate particles to incredible energies, while coronal mass ejections hurl billions of tons of plasma into space at speeds of several thousand kilometers per second. When these solar tsunamis reach Earth, they can compress our magnetosphere, squeeze it like a balloon being pressed between two hands. The aurora oval swells, sometimes expanding so far from the poles that people in surprisingly low latitudes find themselves witnesses to one of nature's most spectacular displays. During these magnetic storms, the aurora can take on characteristics rarely seen during quiet times. Instead of the usual green curtains, observers might witness towering red columns stretching high into the sky, or rapid pulsations that make the entire aurora appear to breathe with light. Sometimes the display becomes so bright that it casts shadows on the snow below, or illuminates the landscape with an otherworldly glow that makes familiar surroundings look like scenes from an alien world. The study of these space weather events has revealed just how connected our planet is to the broader solar system. The same solar storms that create spectacular auroras can also interfere with radio communications, disrupt satellite operations, and even induce electrical currents in power lines and pipelines on Earth's surface. It's a reminder that the boundary between Earth and space isn't as clear-cut as we might think. We live within the extended atmosphere of the Sun, constantly bathed in its influence. Scientists have learned to read the aurora like a cosmic weather report, using ground-based cameras, satellites, and radar systems to monitor the health of Earth's magnetic field. The colors, shapes, and movements of auroral displays provide clues about conditions in the solar wind, the strength of Earth's magnetic field, and the complex processes happening in the magnetosphere. Each flickering curtain of light is like a diagnostic readout from our planet's invisible protective system. The technology we use to study the aurora has evolved dramatically over the past few decades. High-resolution cameras can now capture auroral movements with incredible detail, revealing structures and dynamics that were invisible to earlier observers. Satellite missions provide a bird's-eye view of auroral ovals from space, showing how they expand and contract in response to changing solar conditions. Radar systems can track the movement of particles in the upper atmosphere, while magnetometers on the ground measure the electrical currents flowing overhead. One of the most fascinating aspects of aurora research is how it connects the very large with the very small. The same physics that governs the behavior of individual charged particles also controls the vast streams of plasma flowing through space. Understanding how a single electron spirals along a magnetic field line helps scientists predict how entire regions of the magnetosphere will respond to solar wind disturbances. The aurora also serves as a natural laboratory for studying plasma physics, the behavior of electrically charged gases that make up most of the visible universe. The conditions in Earth's magnetosphere and upper atmosphere provide opportunities to observe plasma phenomena that would be impossible to recreate in terrestrial laboratories. Each auroral display is essentially a massive physics experiment, conducted on a planetary scale using equipment provided by the Sun and Earth themselves. Modern aurora forecasting has become surprisingly sophisticated, with scientists able to predict when and where auroral displays are likely to occur days in advance. They monitor solar activity using spacecraft positioned between Earth and the Sun, tracking coronal mass ejections as they race across space. When these solar storms are detected, alerts go out to aurora enthusiasts around the world, letting them know when to venture outside with their cameras and warm clothes. The democratization of aurora photography has revealed just how common these displays actually are. What once seemed like rare magical events are now understood to be happening constantly somewhere on Earth. Social media feeds during periods of high solar activity fill with images from around the polar regions, green curtains reflected in Norwegian fjords, purple rays dancing over Canadian forests, red auroras crowning the ice fields of Iceland. Yet for all our scientific understanding, the aurora retains its power to inspire wonder. There's something about standing beneath those shifting lights that connects us to both the cosmos and to all the humans who have ever looked up and marvelled at the night sky. The Sami people of northern Scandinavia believed the aurora was the energies of the departed. Aboriginal Australians saw them as spirits dancing around a campfire. The ancient Romans thought they were the goddess of dawn racing across the sky in her chariot. These stories remind us that the aurora has always been more than just a natural phenomenon. It's been a source of meaning, a bridge between the earthly and the divine, a reminder of forces beyond our immediate understanding. Even now, when we can explain the physics behind every photon of auroral light, the experience of watching the northern or southern lights dance across a dark sky remains profoundly moving. The aurora also connects us to the future of human exploration. As we plan missions to Mars and other worlds, understanding space weather becomes increasingly important. Mars, lacking a global magnetic field like Earth's, experiences a very different relationship with the solar wind. Any future Mars explorers will need to understand how solar storms might affect their equipment and their safety. The lessons we learn from studying Earth's aurora will help prepare us for the challenges of living and working in the space environment around other worlds. Some of the most intriguing aurora research focuses on other planets in our solar system. Jupiter, with its enormous magnetic field, hosts auroral displays that dwarf anything seen on Earth. These Jovian auroras are powered not just by the solar wind, but by volcanic emissions from its moon Io, creating displays thousands of times more energetic than Earth's northern lights. Saturn too has its own auroral phenomena, with ultraviolet lights dancing around its poles in patterns that reveal the complex structure of its magnetic field. Even planets we might not expect show auroral activity. Mars, despite its weak magnetic field, occasionally displays faint auroral glows when solar storms interact with residual magnetic fields in its crust. These Martian auroras are much different from Earth's, more diffuse, often appearing as patches of light rather than the familiar curtains we see in polar regions. They're a reminder that the interaction between solar wind and planetary magnetic fields can create beautiful phenomena throughout the solar system. The study of auroras on other worlds helps us understand how common these light displays might be throughout the universe. Any planet with an atmosphere and some form of magnetic field, whether generated by the planet itself or inherited from its star, could potentially host auroral phenomena. This means that somewhere among the thousands of exoplanets we've discovered orbiting other stars, there might be alien worlds where their own versions of the northern lights paint unfamiliar skies with colours we can only imagine. As you settle into sleep tonight, picture yourself as a cosmic voyager, drifting through the solar wind alongside those charged particles that began their journey on the Sunday. Feel yourself carried along by invisible currents of magnetism, guided by field lines that stretch across millions of kilometers of space. Imagine the moment when you finally encounter Earth's magnetic field, that protective bubble that has shielded our world for billions of years. See yourself funneled down toward the poles, spiraling along magnetic highways that channel you toward the upper atmosphere. Feel the anticipation building as you approach that thin boundary between space and air, where your long journey is finally about to end in a burst of green or red or purple light. And then, in that moment of collision with an oxygen or nitrogen atom, release all your energy in one brilliant flash, adding your photon to the vast tapestry of light that has been painting polar skies since Earth first developed its magnetic field. The aurora is always there, somewhere on our planet, a constant reminder of the invisible forces that protect and connect us to the cosmos. Even when clouds hide the stars, even when city lights wash out the night sky, those curtains of light are dancing somewhere above the ice and snow of the polar regions. They're a bridge between worlds, a visible manifestation of the relationship between Earth and Sun, a gentle light show powered by nuclear fusion and guided by magnetism across the vast emptiness of space. Tonight, as charged particles continue their ancient dance along magnetic field lines, as electrons fall back to lower energy states and release their energy as light, the aurora carries on its timeless performance. It's a show that has been running for billions of years and will continue long after we're gone, a cosmic ballet choreographed by physics and painted with the very atoms that make up our world. And there's something particularly magical about the rhythm of auroral activity that mirrors the pulse of life on Earth. Just as our bodies follow circadian rhythms tied to the sun's daily journey across the sky, the aurora follows its own celestial clock. The interaction between Earth's rotation and the steady flow of solar wind creates patterns that repeat with surprising regularity, like a cosmic heartbeat that's been keeping time for eons. During the long Arctic winter, when the sun doesn't rise for months at a time, the aurora becomes the primary source of natural light in the polar regions. Indigenous peoples living in these remote areas have developed an intimate relationship with these lights, reading them like others might read clouds or wind patterns. They can tell from the colour and movement of the aurora what the weather might bring, or when the best time might be for hunting or travelling across the frozen landscape. There's a particular quality to auroral light that photographers struggle to capture and scientists work to quantify. Unlike the harsh glare of electric lights, or even the warm glow of firelight, Auroral illumination has an ethereal quality that seems to come from everywhere and nowhere at once. It's soft yet distinct, bright enough to read by yet gentle enough not to disturb the natural darkness that polar animals depend on for their survival rhythms. The aurora also creates its own microclimate of sorts. The electrical activity associated with intense auroral displays can actually warm the upper atmosphere, causing it to expand slightly. This expansion can affect the orbits of low-flying satellites, requiring mission controllers to adjust their trajectories. It's a reminder that even something as apparently delicate as shimmering lights can have measurable effects on objects hundreds of kilometers away. Climate scientists have discovered that auroral activity correlates with various atmospheric phenomena in ways that are still being understood. The electrical currents flowing through the upper atmosphere during auroral displays can influence wind patterns and temperatures at much lower altitudes. Some researchers suggest that periods of intense auroral activity might even affect weather patterns in ways that cascade down through the atmosphere to influence conditions at ground level. The biological effects of living beneath frequent auroral displays remain largely mysterious. Some studies suggest that animals in polar regions have adapted their behavior to the rhythms of geomagnetic activity, with migration patterns and breeding cycles that seem to correlate with the 11-year solar cycle. Whether this is direct causation or simply correlation remains an open question, but it hints at connections between cosmic events and terrestrial life that we're only beginning to explore. There's also growing interest in how indigenous knowledge about the aurora might inform modern scientific understanding. Traditional stories often contain remarkably accurate observations about auroral behavior, encoded in mythology and passed down through generations. Some of these oral traditions describe auroral phenomena that weren't officially recognized by science until decades or even centuries later, suggesting that careful observation over long periods can reveal patterns that might be missed by shorter-term scientific studies. The aurora has inspired not just scientific inquiry, but also artistic expression throughout human history. Painters have attempted to capture its flowing forms. Musicians have composed pieces that try to echo its ethereal movements. And poets have struggled to find words adequate to describe the experience of standing beneath those dancing lights. There's something about the aurora that seems to activate parts of human consciousness that pure scientific description can't quite reach. Modern technology has allowed us to experience the aurora in ways that would have been impossible for earlier generations. Time-lapse photography reveals the intricate choreography of auroral movements that unfold too slowly for the naked eye to follow. High-resolution cameras can capture colors and structures that are too faint or too brief for human vision to detect. Satellite imagery shows us the aurora from above, revealing the vast scale of these displays and how they connect across entire hemispheres. Yet for all our technological advances, there's still something irreplaceable about the direct experience of witnessing the aurora with your own eyes. The way the light seems to move with purpose, the silence that accompanies even the most dramatic displays, the sense of scale that comes from standing on Earth's surface while looking up at phenomena occurring hundreds of kilometers overhead. These elements combine to create an experience that no photograph or video can fully capture. The aurora also serves as a bridge between different ways of knowing. Traditional ecological knowledge, passed down through indigenous communities over thousands of years, often contains insights about auroral behavior that complement and sometimes even surpass modern scientific understanding. These different knowledge systems, when brought together respectfully, can provide a more complete picture of how the aurora fits into the broader patterns of Earth systems. As our understanding of the aurora has deepened, so has our appreciation for the delicate balance of forces that make these displays possible. The strength of Earth's magnetic field, the composition of our atmosphere, our distance from the sun, even the tilt of our planet's axis. All of these factors must be just right for the aurora to exist as we know it. It's a reminder of how precisely tuned our planet is for the phenomena we take for granted. The future of aurora research promises even more revelations about these mysterious lights. New satellite missions are planned that will provide unprecedented views of how the solar wind interacts with Earth's magnetic field. Ground-based networks of cameras and sensors are becoming more sophisticated, able to track auroral movements with increasing precision. Citizen scientists armed with smartphones and digital cameras are contributing observations from locations around the globe, creating a more complete picture of auroral activity than ever before possible. There's also growing interest in using artificial intelligence to predict auroral activity with greater accuracy. Machine learning algorithms trained on decades of solar wind data and auroral observations are beginning to identify patterns that human researchers might miss. These systems might eventually be able to forecast not just when the aurora will be active, but what colors and shapes are most likely to appear in specific locations. The connection between the aurora and human technology continues to evolve as well. While magnetic storms can disrupt our electronic systems, engineers are learning to design more resilient infrastructure that can withstand these space weather events. Some researchers are even exploring whether the electrical currents associated with the aurora might someday be harnessed as a source of renewable energy, though the technical challenges remain formidable. The aurora also plays an increasingly important role in space exploration planning. As humans venture farther from Earth's protective magnetic field, understanding how solar radiation and charged particles affect both equipment and human health becomes crucial. The aurora serves as a constant reminder of the energetic environment that exists throughout the solar system, helping us prepare for the challenges of long-duration space missions. Education programs around the world are using the aurora as a gateway to teach students about physics, astronomy, and earth science. There's something particularly engaging about a natural phenomenon that students can potentially see with their own eyes, rather than just read about in textbooks. Aurora watching expeditions have become popular ways to combine scientific education with adventure travel, bringing people to remote locations where they can experience both the lights themselves and the cultures of the people who live beneath them. The aurora also continues to inspire new technologies for studying Earth's upper atmosphere. Rocket missions launched into active auroral displays provide direct measurements of particle densities and energy levels that can't be obtained any other way. These brief flights, lasting only minutes, can gather data that takes months or years to fully analyze, revealing new details about the complex physics occurring in the region where Earth meets space. Some of the most intriguing auroral research focuses on the rapid variations that occur within displays, flickering and pulsations that happen on timescales of seconds or less. These phenomena, invisible to casual observers but detectable by sensitive instruments, may hold clues about fundamental processes in plasma physics that occur throughout the universe. Understanding these rapid variations could help scientists better comprehend everything from solar flares to the behavior of matter near black holes. The global nature of auroral activity has become more apparent as communication networks have improved. Aurora enthusiasts around the world now share real-time reports and images, creating a continuous picture of how these displays evolve across both hemispheres. What emerges from these collaborative observations is a sense of the aurora as a truly planetary phenomenon, with northern and southern lights often mirroring each other in response to the same solar wind disturbances. Climate change research has also begun to examine how auroral activity might be affected by changes in Earth's upper atmosphere. As greenhouse gases alter the density and temperature of the thermosphere, the atmospheric layer where most auroral activity occurs, scientists are working to understand whether these changes might affect the appearance or behavior of the aurora itself. It's yet another way that human activity on Earth's surface might have consequences that reach all the way to the edge of space. The study of historical auroral records has revealed fascinating patterns in past solar activity. Medieval chronicles, ship logs, and other historical documents contain accounts of unusual auroral displays that help scientists reconstruct solar behavior from centuries past. Some of these historical auroras were seen at remarkably low latitudes, suggesting solar storms of extraordinary intensity that dwarf anything recorded in the modern era. These historical studies also reveal how human interpretation of the aurora has changed over time. What medieval chroniclers described as omens or supernatural phenomena, we now understand as natural consequences of solar activity. Yet the sense of wonder and mystery that these displays inspired in our ancestors remains largely unchanged. The aurora continues to evoke feelings of awe and connection to something larger than ourselves, regardless of how well we understand the physics behind it. As you drift deeper into relaxation tonight, imagine the aurora as Earth's way of dreaming a gentle light show that plays out in the thin air above the polar regions while most of the planet sleeps. Picture those charged particles as cosmic messengers, carrying stories from the sun about nuclear furnaces and magnetic fields, about the vast emptiness of space, and the journey across 93 million miles of nothingness. Think of the aurora as a conversation between worlds, a dialogue conducted in the language of light and magnetism. The sun speaks in streams of particles and bursts of radiation. Earth responds with its magnetic field, deflecting and channeling these solar utterances into patterns of beauty that dance across the polar skies. And we, standing on the surface of our planet, are privileged eavesdroppers on this cosmic conversation, witnesses to an exchange that has been ongoing since our world first developed its protective magnetic shield. The aurora connects us to timescales that stretch far beyond human experience. The magnetic field that guides those dancing lights is generated deep within Earth's core, where liquid iron flows in patterns that have persisted for billions of years. The particles creating tonight's display began their journey in nuclear reactions that might have occurred before humans existed, slowly working their way from the sun's core to its surface over hundreds of thousands of years. Even the atoms that glow when struck by these solar particles have their own ancient stories. The oxygen that produces those familiar green curtains was forged in the cores of massive stars that lived and died long before our solar system formed. The nitrogen that contributes blue and purple hues to the auroral palette was created in stellar furnaces and scattered into space by supernova explosions. Every auroral display is thus a reunion of cosmic elements, brought together by chance across vast distances and eons of time. There's something profoundly peaceful about this perspective, the idea that the aurora represents a kind of cosmic recycling, where matter and energy flow in great cycles that connect stars and planets across space and time. The same carbon atoms in your body might once have been part of an ancient star. The iron in your blood was forged in stellar cores and scattered by supernovas. And the light from tonight's aurora connects you to nuclear processes happening right now in the sun 93 million miles away. The aurora also reminds us of the invisible connections that bind us to the cosmos. We tend to think of ourselves as separate from space, protected by our atmosphere and isolated on our planetary island. But the aurora reveals that we live within the extended atmosphere of the sun, constantly bathed in its influence. The same magnetic field that creates those dancing lights also protects us from harmful radiation, maintaining the stable environment that allows life to flourish. As the night deepens and your thoughts grow quieter, let the aurora carry you into dreams filled with dancing lights and cosmic connections. Imagine yourself floating among those charged particles as they spiral down magnetic field lines, witnessing the moment when invisible forces become visible beauty. Feel yourself becoming part of that ancient dialogue between sun and earth, between the nuclear fires of our nearest star and the magnetic embrace of our home planet. The aurora will continue its gentle dance long after you've drifted off to sleep, painting the polar skies with colors that have no names, telling stories in a language of light that predates human speech. It's a reminder that beauty exists everywhere in the universe, often in places and at scales we rarely think about. From the quantum dance of electrons changing energy levels to the vast choreography of magnetic fields spanning millions of kilometers, the cosmos is full of elegant phenomena waiting to be discovered and appreciated. Tonight, as you rest beneath the same sky that hosts these magnificent light displays, remember that you're part of this cosmic story. The elements in your body, the air you breathe, the planet that holds you, all of these are connected to the same processes that create the aurora. You are literally made of star stuff, participating in a universe that expresses itself in countless ways, from the grand spiral of galaxies to the gentle glow of dancing lights above the poles. The aurora awaits, patient and eternal, ready to paint the darkness with its ancient artistry whenever the solar wind carries the right conditions across the void. And somewhere, perhaps right now, those curtains of light are beginning to shimmer and dance, adding another chapter to the longest-running light show in the solar system. The dance of the aurora isn't confined to Earth alone, though ours may be the most familiar to us. Across the solar system, other worlds host their own versions of these celestial light shows, each one shaped by the unique characteristics of their magnetic fields, atmospheres, and distances from the Sunday. These alien auroras offer us glimpses into how the same fundamental physics plays out in dramatically different environments. Jupiter, that massive gas giant with its swirling storms and collection of moons, produces auroral displays that dwarf anything we see on Earth. The Jovian aurora is powered not just by the solar wind, but by the volcanic activity of its moon Io, which spews charged particles into Jupiter's enormous magnetosphere. These auroras glow primarily in ultraviolet light, invisible to human eyes but spectacular when viewed through the right instruments. They pulse and flicker with energies thousands of times greater than Earth's northern lights, painting Jupiter's polar regions with patterns that reveal the complex interaction between the planet's magnetic field and the streams of particles flowing through its system. Saturn, too, hosts its own auroral phenomena, with displays that appear as shimmering ovals around the planet's poles. What makes Saturn's auroras particularly intriguing is how they respond to changes in the solar wind. When the solar wind pressure increases, Saturn's aurora can brighten dramatically, expanding toward the equator in much the same way that Earth's aurora oval grows during magnetic storms. The hexagonal cloud pattern at Saturn's north pole adds an extra layer of mystery, creating a geometric backdrop against which these lights play out their cosmic choreography. Even distant Uranus and Neptune, those ice giants at the edge of our solar system, show signs of auroral activity. Their magnetic fields are tilted at odd angles relative to their rotation axes, creating auroral patterns unlike anything seen closer to the Sunday. These far-flung auroras are dim and difficult to detect, but they remind us that the interaction between solar wind and planetary magnetic fields continues even at the cold, dark margins of our solar system. Perhaps most intriguingly, Mars occasionally displays its own faint auroral glows, despite lacking the strong global magnetic field that creates Earth's dramatic displays. Instead, Mars's auroras are powered by interactions between the solar wind and localized magnetic fields trapped in the planet's crust remnants of an ancient global magnetic field that died out billions of years ago. These Martian auroras appear as diffuse patches of light rather than the familiar curtains we see on Earth, glowing faintly in the thin atmosphere above regions where the ancient magnetic fields still persist. The discovery of auroras on other worlds has expanded our understanding of how common these phenomena might be throughout the universe. Any planet or moon with some combination of magnetic field and atmosphere could potentially host auroral displays. This means that among the thousands of exoplanets we've discovered orbiting distant stars, there might be alien worlds where their own versions of dancing lights paint unfamiliar skies with colors we can only imagine. Some of these exoplanets orbit much closer to their stars than Earth does to the Sun, bathed in stellar winds far more intense than anything in our solar system. The auroras on such worlds might be spectacular beyond anything we've ever witnessed, permanent storms of light that never fade, powered by the constant bombardment of charged particles from their nearby stars. Other planets might orbit dim red dwarf stars, their auroras flickering weakly in the faint stellar light, creating subtle displays visible only to eyes adapted to perpetual twilight. The study of auroras on other worlds also helps us understand Earth's aurora in new ways. By comparing how different planetary magnetic fields interact with their stellar environments, scientists can better understand the fundamental processes that create these light displays. Each world becomes a natural laboratory, offering unique conditions that test our theories about plasma physics and magnetosphere dynamics. There's something wonderfully humbling about realizing that the aurora we see dancing above Earth's poles is part of a much larger cosmic phenomenon. The same physics that creates our northern and southern lights is at work throughout the universe, wherever charged particles encounter magnetic fields and atmospheres. It's a reminder of the underlying unity that connects all cosmic phenomena, from the smallest interactions between individual particles to the grandest displays of light spanning entire planetary systems. The colors of alien auroras would depend on the atmospheric composition of each world. While Earth's aurora glows primarily in the green of oxygen and the blue and purple of nitrogen, an exoplanet with a methane-rich atmosphere might produce auroras in entirely different hues. Worlds with thick carbon dioxide atmospheres might glow with colors that have no names in human language. Some alien auroras might even occur in wavelengths completely invisible to human eyes, detectable only by instruments sensitive to infrared or ultraviolet light. The shapes these alien auroras take would be equally varied, determined by the unique magnetic field geometry of each world. A planet with multiple magnetic poles might host several separate auroral ovals. A world with a magnetic field that changes rapidly over time might display auroras that shift and morph in ways completely unlike the relatively stable patterns we see on Earth. Some planets might have magnetic fields so strong that their auroras extend far into space, creating luminous sheaths around the entire world. The intensity of these displays would vary dramatically as well. Planets orbiting quiet, stable stars might have gentle, subtle auroras that barely disturb the darkness. Worlds circling active, flare-prone stars might be subjected to auroral storms of incredible violence, with displays so bright they outshine the planet's surface features. Some exoplanets might experience auroral seasons, with displays that wax and wane as their orbits carry them closer to and farther from their stars. Even within our own solar system, we're still discovering new aspects of auroral phenomena. Jupiter's moon, Ganymede, despite being a moon rather than a planet, has its own magnetic field and thin atmosphere, creating the conditions for small-scale auroral displays. These Ganymedean auroras are incredibly faint, detectable only by sensitive space-based instruments, but they represent yet another variation on the auroral theme. The moons of other gas giants might host their own auroral displays as well. Enceladus, Saturn's ice-covered moon that spews water vapor into space through geysers at its south pole, creates a torus of charged particles around Saturn. When these particles rain back down onto Enceladus's surface, they might create auroral glows in the tenuous atmosphere above the geysers. Europa, Jupiter's ice-covered moon with its subsurface ocean, might experience similar phenomena as charged particles from Jupiter's magnetosphere interact with the thin oxygen atmosphere created by radiation-splitting water molecules on the moon's surface. The study of these diverse auroral phenomena is pushing the boundaries of our understanding of plasma physics. Each new discovery, whether it's the hexagonal aurora at Saturn's pole or the patchy displays on Mars, provides new data points for testing and refining our theories about how charged particles behave in magnetic fields. These cosmic laboratories offer conditions that can't be replicated on Earth, allowing us to study plasma physics on scales and in environments impossible to create in terrestrial experiments. Future space missions will undoubtedly reveal even more auroral phenomena throughout the solar system and beyond. Advanced telescopes might eventually be able to detect the auroral glows of distant exoplanets, adding another tool to the arsenal of techniques used to study worlds orbiting other stars. The colours and patterns of these distant auroras could provide clues about the atmospheric composition and magnetic field structure of alien worlds. There's a poetic quality to the idea that auroras might be universal phenomena, lighting up skies throughout the cosmos. Every star system might have its own versions of dancing lights, each one unique but governed by the same fundamental physics. The northern and southern lights that paint Earth's polar skies are thus part of a cosmic symphony of light, with variations playing out on countless worlds across the galaxy. The search for life elsewhere in the universe might even benefit from studying auroral phenomena. Strong magnetic fields that create dramatic auroras also provide protection from harmful stellar radiation, potentially making planets more habitable for life as we know it. Worlds with active, vibrant auroras might be more likely to harbour the stable conditions necessary for life to emerge and evolve. As we've learned more about the incredible diversity of auroral phenomena throughout the solar system, we've also gained a deeper appreciation for Earth's own aurora. Our planet's magnetic field, while not the strongest in the solar system, creates conditions that are particularly favourable for the kinds of auroral displays we find so beautiful. The combination of Earth's magnetic field strength, atmospheric composition, and distance from the Sun creates auroras that are both spectacular and accessible to human observation. The aurora has become a bridge between Earth-based science and space exploration. The same instruments and techniques used to study Earth's aurora from the ground are now being adapted for use on spacecraft, exploring other worlds. The knowledge gained from decades of aurora research on Earth provides the foundation for understanding the auroral phenomena we're discovering throughout the solar system. This cosmic perspective on the aurora also reminds us of our place in the larger universe. We're not isolated observers of a purely terrestrial phenomenon, but participants in cosmic processes that play out on scales from individual atoms to entire planetary systems. The particles that create Earth's aurora have travelled across the solar system. The magnetic fields that guide them connect our planet to the Sun and to the broader galactic environment in which our solar system moves. The aurora thus becomes a symbol of connection not just between Earth and Sun, but between our world and the countless other worlds where similar phenomena might be occurring. Every time we look up at the dancing lights above our polar regions, we're seeing evidence of processes that link us to the broader cosmos, reminders that we live in a universe where the same physical laws create beauty and wonder on scales both intimate and vast. As you settle deeper into relaxation tonight, imagine yourself as a cosmic traveller, visiting these alien worlds where auroras paint unfamiliar skies with impossible colours. Picture Jupiter's volcanic moon Io, its surface glowing red with molten sulfur, while brilliant auroras dance in the Jovian magnetosphere overhead. Envision Saturn's hexagonal polar storm, with auroral lights flickering around its geometric edges like cosmic lightning. Think about those distant exoplanets, worlds orbiting stars we can barely see, where auroras might glow in the light of red dwarf suns or flare brilliantly around planets tidally locked to their stars. Imagine the colours these alien auroras might display, hues created by atmospheric gases that don't exist on Earth, patterns shaped by magnetic fields, unlike anything in our solar system. The universe is vast and full of wonders we're only beginning to discover, but the aurora reminds us that beauty and elegance are woven into the very fabric of physical reality. The same processes that create Earth's gentle green curtains also paint the skies of distant worlds with their own unique palettes of light. We are part of a cosmos where charged particles and magnetic fields collaborate to create art on a planetary scale where the laws of physics express themselves as beauty across countless worlds. Tonight, as the solar wind continues its eternal flow outward from the Sun, it carries with it the potential for auroral displays throughout the solar system. On worlds we've never seen, magnetic fields may be channeling stellar particles into glowing curtains of light. In star systems beyond our current reach, alien auroras might be dancing above the poles of worlds where other forms of life look up in wonder at their own version of the northern lights. The aurora connects us not just to our sun and our own magnetic field, but to the fundamental processes that shape the universe itself. It's a reminder that we live in a cosmos where matter and energy flow in great cycles, where stars and planets engage in invisible conversations conducted through magnetic fields and streams of charged particles. Every auroral display is evidence of these cosmic connections, proof that we are part of something much larger and more beautiful than our daily experience might suggest. As your consciousness begins to drift toward the peaceful realm of sleep, let the aurora carry you on journeys to distant worlds. Float among the charged particles as they spiral through alien magnetospheres. Witness the moment when invisible forces become visible light on planets whose names we don't yet know. Feel yourself becoming part of that universal dance of matter and energy that creates beauty wherever the right conditions come together. The aurora awaits on countless worlds, patient and eternal, ready to paint the darkness with light whenever stellar winds meet planetary magnetic fields. It's a phenomenon as old as planets themselves, a cosmic constant that has been creating beauty in the universe for billions of years. And somewhere out there, perhaps right now, alien auroras are beginning to shimmer and dance, adding their own chapters to the endless story of light and magnetism that connects all worlds beneath all stars. Sleep peacefully, knowing that you are part of this cosmic tapestry, woven into a universe where the same forces that protect our planet also create some of the most beautiful displays of light imaginable. The aurora dances on, here and throughout the cosmos, a gentle reminder that we live in a universe where physics and beauty are one and the same. The relationship between the aurora and human consciousness runs deeper than we might initially realize. There's something about witnessing these dancing lights that seems to activate parts of our awareness that remain dormant in ordinary life. Perhaps it's the way auroral displays unfold on timescales that match the rhythm of contemplation, slow enough to follow with the eye, yet dynamic enough to hold attention in a state of gentle fascination. Standing beneath an active aurora, observers often report a peculiar sense of time dilation. Minutes can feel like hours as consciousness expands to match the scale of the phenomenon overhead. The usual chatter of daily thoughts quiets, replaced by something more fundamental, a direct, wordless appreciation for the elegant physics playing out hundreds of kilometers above. It's as if the aurora creates a natural meditation, drawing awareness into the present moment through the simple act of witnessing beauty in motion. This meditative quality of aurora observation has been recognized by cultures around the polar regions for thousands of years. Traditional knowledge holders speak of the lights as teachers, sources of wisdom that can only be received in states of quiet receptivity. They describe how extended periods of aurora watching can shift perception, opening awareness to subtle patterns and connections that remain invisible during ordinary states of consciousness. Modern research into the psychological effects of aurora observation has revealed some fascinating correlations. People who spend significant time watching the northern or southern lights often report enhanced creativity, improved problem-solving abilities, and a greater sense of connection to natural systems. Whether these effects result from the aurora itself or from the contemplative state it induces remains an open question, but the benefits appear to be real and measurable. There's also something profound about the way the aurora connects us to invisible realms of existence. While we can see the lights themselves, the magnetic field lines that guide them remain forever hidden from direct perception. This creates a unique experience of witnessing effects, while being unable to see their causes, a reminder that much of reality operates beyond the range of our immediate senses. The aurora thus becomes a bridge between the visible and invisible aspects of our world. It makes tangible the otherwise abstract concepts of magnetic fields and charged particle interactions. When we watch those curtains of light ripple and flow, we're seeing the shape of Earth's magnetosphere made manifest, the invisible architecture of our planet's protective shield revealed through the gentle collision of solar particles with atmospheric gases. This quality has made the aurora a powerful educational tool for helping people understand complex scientific concepts. Teachers in polar regions often use aurora displays as natural classrooms, pointing out how the lights follow magnetic field lines or explaining how different colors correspond to different altitudes and atmospheric compositions. Students who learn about electromagnetism while watching actual auroral displays tend to develop a much more intuitive understanding of these phenomena than those who encounter them only through textbooks and diagrams. The aurora also serves as a reminder of the delicate balance that makes life on Earth possible. Those same charged particles that create such beautiful displays could be harmful to living organisms if they reached the surface in large quantities. The fact that we can enjoy auroral beauty from the safety of Earth's surface is a testament to the effectiveness of our planet's magnetic shielding system. This protective aspect of Earth's magnetic field becomes particularly relevant as we consider the future of human space exploration. Astronauts traveling beyond the magnetosphere's protection will be exposed to the same charged particle environment that creates the aurora. Understanding how these particles affect both equipment and human physiology is crucial for planning long-duration missions to Mars and other destinations. The aurora research conducted on Earth thus serves a dual purpose, satisfying our scientific curiosity about these beautiful phenomena, while also preparing us for the practical challenges of living and working in the space environment. Every measurement of particle energies and magnetic field fluctuations adds to our knowledge base for designing spacecraft shielding and predicting space weather hazards. Some of the most intriguing auroral research focuses on the acoustic phenomena that sometimes accompany bright displays. For centuries, observers have reported hearing crackling, hissing, or whooshing sounds during intense auroral activity. Scientists initially dismissed these reports, reasoning that the aurora occurs far too high in the atmosphere for sound waves to propagate to ground level. However, recent studies have revealed that the electromagnetic fields associated with auroral displays can indeed create audible effects, though not through conventional sound wave propagation. Instead, these fields may interact with objects near the observer hair, clothing, vegetation, causing them to vibrate in ways that produce sound. The result is an eerie accompaniment to the visual display, as if the aurora is singing its own ethereal soundtrack. This acoustic dimension adds another layer to the auroral experience, engaging multiple senses simultaneously. Observers who have heard these sounds describe them as otherworldly, unlike anything else in their experience. The combination of visual beauty and mysterious sounds creates an immersive experience that can be profoundly moving, even for those who understand the scientific explanations behind both phenomena. The psychological impact of witnessing the aurora extends beyond individual experience to influence entire communities and cultures. In regions where auroral displays are frequent, they become woven into the fabric of daily life, influencing everything from folklore and art to practical decisions about when to travel or conduct outdoor activities. The aurora becomes part of the cultural landscape, as integral to local identity as mountains or rivers might be in other regions. This cultural integration of the aurora reflects a deeper truth about human nature, our innate tendency to find meaning and beauty in natural phenomena. The aurora speaks to something fundamental in human consciousness, a capacity for wonder that transcends scientific understanding. Even when we can explain every aspect of how these lights are created, they retain their power to inspire awe and contemplation. The aurora also demonstrates how scientific knowledge can enhance rather than diminish our appreciation of natural beauty. Understanding the journey that solar particles take from the sun's core to Earth's upper atmosphere, the complex interactions between magnetic fields and charged particles, the precise mechanisms that create different colors and shapes, all of this knowledge adds depth and richness to the experience of witnessing an auroral display. Rather than reducing the aurora to mere physics, scientific understanding reveals it as an expression of cosmic processes that connect our planet to the broader universe. Each photon of auroral light carries within it the story of nuclear fusion in the Sun's core, the journey through space at incredible velocities, the dance with Earth's magnetic field, and the final collision that transforms invisible energy into visible beauty. This narrative dimension of the aurora, the story embedded within each display, resonates with humans' love of storytelling. We are creatures who understand the world through narratives, and the aurora provides one of the most compelling stories in all of natural science. It's a tale that spans scales from the subatomic to the planetary, from microseconds to billions of years, from the familiar environment of Earth's surface to the alien realm of interplanetary space. The aurora also serves as a reminder of our planet's dynamic nature. While we often think of Earth as stable and unchanging on human timescales, the aurora reveals it as an active participant in solar system processes. Our planet's magnetic field is constantly responding to changes in the solar wind, expanding and contracting like a living thing breathing in response to its environment. This dynamic quality extends to the magnetic field itself, which is generated by convection currents in Earth's liquid outer core. These currents change over time, causing the magnetic field to shift and fluctuate. The magnetic poles wander across Earth's surface, following paths that reflect the complex fluid dynamics occurring thousands of kilometers beneath our feet. Occasionally, Earth's magnetic field undergoes dramatic changes called geomagnetic reversals, where the north and south magnetic poles essentially flip positions. These reversals occur irregularly, sometimes separated by hundreds of thousands of years, other times happening much more frequently. During the transition period, the magnetic field weakens significantly, potentially allowing more cosmic radiation to reach Earth's surface and creating unusual auroral displays at unexpected latitudes. The study of past geomagnetic reversals recorded in the magnetic orientation of ancient rocks has revealed that these events are a normal part of Earth's long-term evolution. They remind us that even the fundamental characteristics of our planet, like the protective magnetic field that creates the aurora, are subject to change over geological timescales. Understanding these long-term magnetic variations has implications for both aurora science and astrobiology. During periods of weak magnetic field strength, the aurora might appear at much lower latitudes than usual, potentially visible to human populations that normally never see these displays. Conversely, a weakened magnetic field would also expose Earth's surface to higher levels of cosmic radiation, with potential consequences for both technological systems and biological evolution. The aurora thus serves as a window into Earth's deep history and distant future. By studying how auroral activity has varied over time, scientists can reconstruct changes in both solar activity and Earth's magnetic field strength. Ancient auroral records, preserved in historical documents and geological formations, provide clues about conditions in past centuries and millennia. Some of the most dramatic historical auroral events were recorded during periods of intense solar activity. The Carrington event of 1859, named after the British astronomer who observed the solar flare that caused it, produced auroral displays visible as far south as the Caribbean and Hawaii. Telegraph systems around the world were disrupted, with some operators receiving electric shocks and telegraph paper catching fire from the induced currents. If a similar event occurred today, the consequences would be far more severe, given our dependence on electronic systems. Modern infrastructure, power grids, satellite networks, GPS systems, internet communications could all be affected by the intense magnetic disturbances that accompany extreme auroral displays. This has led to increased efforts to monitor space weather and develop early warning systems for potentially hazardous solar storms. The aurora has thus evolved from a purely aesthetic phenomenon to one with significant practical implications for technological civilization. The same beautiful displays that inspire wonder and contemplation also serve as indicators of conditions that could affect everything from airplane navigation to credit card transactions. This dual nature, simultaneously beautiful and potentially disruptive, reflects the complex relationship between human technology and natural systems. As our technological capabilities have advanced, so has our ability to study and predict auroral activity. Modern aurora research employs an impressive array of tools, from ground-based cameras and magnetometers to satellite-based particle detectors and imaging systems. This multi-platform approach allows scientists to study the aurora from multiple perspectives simultaneously, creating a comprehensive picture of the processes involved. One of the most significant advances in aurora research has been the development of all-sky camera networks that continuously monitor auroral activity across vast regions. These automated systems can detect and track auroral displays even when no human observers are present, creating an unprecedented database of auroral behavior patterns. Time-lapse sequences from these cameras reveal the intricate choreography of auroral movements, showing how displays evolve over periods of hours or days. Citizen science has also played an increasingly important role in aurora research. Apps and websites allow aurora enthusiasts around the world to report sightings and share photographs, creating a global network of observers that complements professional monitoring systems. This crowdsourced approach has proven particularly valuable for studying unusual auroral phenomena that might be missed by automated systems. The democratization of aurora photography through digital cameras and smartphones has also contributed to scientific understanding. High-quality auroral images from amateur photographers often reveal details and structures that help researchers understand the physics of auroral formation. Some of the most spectacular auroral photographs in recent years have come from dedicated amateurs who spend countless hours in remote locations waiting for the perfect conditions. Social media has transformed how auroral displays are shared and experienced, creating virtual communities of aurora enthusiasts who communicate across continents. During periods of high auroral activity, these networks buzz with real-time reports and images, creating a sense of shared experience among people who might never meet in person but are united by their fascination with these celestial lights. The global nature of aurora watching has also highlighted the importance of preserving dark skies for both scientific observation and human enjoyment. Light pollution from cities and towns can wash out all but the brightest auroral displays, making it increasingly difficult to observe these phenomena from populated areas. This has led to efforts to establish dark sky preserves and promote lighting practices that minimize interference with natural nighttime environments. The aurora has become a symbol of what we stand to lose if we don't carefully manage our relationship with the night sky. These displays have inspired humans for thousands of years, but they may become increasingly inaccessible to future generations if light pollution continues to spread. Protecting our ability to see and appreciate the aurora thus becomes part of a broader effort to preserve humanity's connection to the natural world. As you continue to relax and let these thoughts settle gently in your mind, consider the profound interconnectedness that the aurora represents. These dancing lights connect us not only to the sun and to the cosmos beyond, but to all the humans throughout history who have looked up in wonder at the same phenomenon. We share this experience across cultures, across centuries, across the vast expanses of space and time that separate us from our ancestors and descendants. The aurora reminds us that we are part of something much larger than our individual lives or immediate concerns. We live within the influence of our star, protected by our planet's magnetic embrace, witnesses to processes that have been unfolding for billions of years and will continue long after we are gone. There's something both humbling and comforting about this perspective, a reminder that our brief existence takes place within the context of cosmic forces of unimaginable scale and beauty. Tonight, As solar particles continue their journey from the sun's surface toward Earth's magnetic field, as electrons spiral down field lines toward their collision with atmospheric atoms, as those collisions release photons that paint the polar skies with ancient light, the aurora carries on its timeless performance. It dances for the caribou and polar bears, for the researchers at remote weather stations, for the indigenous peoples whose ancestors have watched these same lights for countless generations. The aurora dances for you too, even if you can't see it from where you lie tonight. Somewhere above the Arctic ice or the Antarctic plateau, curtains of green and red and purple light are swaying in the solar wind, guided by invisible magnetic highways, powered by nuclear fires burning 93 million miles away. It's a performance that requires no audience but rewards any who take the time to witness it. A cosmic ballet choreographed by physics and performed with the elements that make up our world. As your thoughts grow quieter and your breathing deeper, let the aurora carry you toward peaceful dreams filled with dancing lights and cosmic connections. Feel yourself floating among those charged particles as they complete their journey from sun to earth. Witness the moment when invisible energy becomes visible beauty. Become part of that ancient dialogue between stellar wind and planetary magnetism that has been creating aurora for as long as worlds have had magnetic fields and atmospheres to paint with light. The aurora will continue its gentle dance throughout the night and into tomorrow, a constant reminder that we live in a universe where beauty emerges naturally from the interplay of fundamental forces. It connects us to our sun, to our planet's protective embrace, and to the long history of humans who have found wonder and meaning in the lights that dance across polar skies. Sleep well, knowing that somewhere in the darkness above, the aurora is painting the night with colours that have no names, telling stories in a language older than words, continuing the endless conversation between earth and sky that began when our planet first learned to sing with light. The aurora's influence on human consciousness extends beyond mere visual spectacle into realms that touch something fundamental about how we perceive our place in the universe. There's a quality to auroral light that differs from any other illumination we encounter in daily life. It's neither the harsh glare of artificial lighting nor the familiar warmth of sunlight, but something altogether more ethereal, more mysterious. When you stand beneath an active auroral display, time seems to behave differently. The usual rush of thoughts that characterizes modern life gradually quiets, replaced by something more contemplative, more present. It's as if the aurora creates its own temporal bubble, where the ordinary concerns of daily existence fade into the background, and you become acutely aware of your position on a spinning planet beneath dancing lights powered by nuclear fusion 93 million miles away. This altered state of consciousness isn't merely poetic fancy, it reflects something real about how our minds respond to phenomena that operate on scales both vast and immediate. The aurora unfolds slowly enough for us to follow its movements with our eyes, yet dynamically enough to hold our attention in a state of gentle fascination. It's precisely the right speed to match the natural rhythms of human contemplation, creating a kind of moving meditation that requires no instruction or effort. Indigenous peoples of the Arctic have long recognized this contemplative quality of the aurora. Traditional knowledge holders describe how extended periods of aurora watching can shift awareness, opening perception to patterns and connections that remain hidden during ordinary states of consciousness. They speak of the lights as teachers, sources of wisdom that can only be received in states of receptive stillness. The aurora also serves as a bridge between the visible and invisible aspects of reality. While we can see the dancing lights themselves, the magnetic field lines that guide them remain forever hidden from direct perception. This creates a unique experience of witnessing effects, while being unable to see their causes, a gentle reminder that much of what governs our world operates beyond the range of our immediate senses. When aurora photographers set up their cameras for long exposures, they often capture structures and details invisible to the naked eye. These images reveal the aurora's true complexity, delicate filaments and spirals that mirror the invisible architecture of Earth's magnetic field. The photographs become maps of the unseen, making tangible the otherwise abstract concepts of magnetosphere dynamics and particle physics. The colors captured in these images tell their own stories about the heights at which different interactions occur. The familiar green glow happens at altitudes where oxygen atoms are most abundant and energetic enough to produce that characteristic emission. Higher up, where the atmosphere grows thinner, oxygen can create deep red colors, the same atoms, but responding to different conditions in that twilight realm where space begins to blend with atmosphere. Sometimes, particularly during intense solar storms, rare colors appear in the aurora, yellows and oranges that result from complex combinations of different atmospheric gases being excited simultaneously. These unusual hues are like cosmic footnotes, brief glimpses of the full spectrum of processes happening far above our heads. Experienced aurora watchers treasure these moments, understanding that they're witnessing interactions that might not occur again for months or years. The shapes that auroras take are equally varied and meaningful. The classic curtain-like appearance happens when particles follow magnetic field lines that are roughly parallel to each other, creating those vertical columns of light that seem to hang from the sky like luminous drapes. But magnetic field lines aren't always so orderly. They can twist and curve, creating spiral patterns or converging toward a point to produce what's called a corona, where rays of light seem to radiate outward from directly overhead. Pulsating auroras flicker with a rhythm that can be almost hypnotic, like a cosmic heartbeat made visible. These occur when the stream of particles arriving from space varies in intensity, perhaps due to changes in the solar wind or fluctuations in Earth's magnetic field. The result is an aurora that seems to breathe with light, brightening and fading in cycles that can last anywhere from seconds to minutes. The most dramatic auroral displays often occur during what scientists call substorms, sudden, explosive brightening events that can transform a quiet aurora into a dazzling spectacle within minutes. During a substorm, what might have been a faint arc of green light suddenly erupts into brilliant curtains that dance rapidly across the sky, sometimes accompanied by the mysterious crackling sounds that observers have reported for centuries. These acoustic phenomena add another dimension to the auroral experience. For years, scientists were skeptical of reports that the aurora could be heard, reasoning that it occurs far too high in the atmosphere for sound waves to propagate to ground level. However, recent research suggests that the electromagnetic fields associated with intense auroral displays can create audible effects much closer to Earth's surface, perhaps through interactions with objects like vegetation, hair, or clothing. The sounds are described as otherworldly crackling, hissing, or whooshing noises that seem to come from everywhere and nowhere at once. They add an eerie soundtrack to the visual display, engaging multiple senses simultaneously in an experience that many observers find profoundly moving. Even for those who understand the scientific explanations, the combination of dancing lights and mysterious sounds creates an encounter with nature that transcends mere intellectual appreciation. The aurora's influence extends beyond individual experience to shape entire cultures and communities. In regions where auroral displays are frequent, they become integrated into the fabric of daily life, influencing folklore, art, and even practical decisions about when to travel or conduct outdoor activities. The lights become part of the cultural landscape, as fundamental to local identity as mountains or rivers might be elsewhere. This cultural integration reflects something deeper about human nature, our innate capacity to find meaning and beauty in natural phenomena. The aurora speaks to something fundamental in consciousness, a sense of wonder that persists regardless of scientific understanding. Even when we can explain every aspect of how these lights are created, they retain their power to inspire awe and contemplation. Modern aurora research has revealed that scientific knowledge enhances rather than diminishes our appreciation of these displays. Understanding the epic journey that particles take from the sun's core to Earth's upper atmosphere, the complex choreography of magnetic fields and charged particles, the precise mechanisms that create different colors and patterns, all of this adds depth and richness to the experience of witnessing an auroral display. The aurora tells a story that spans scales from the subatomic to the planetary, from microseconds to geological ages. It's a narrative that begins with nuclear fusion in the sun's core, continues through the vast emptiness of interplanetary space, and concludes with the gentle collision that transforms invisible energy into visible beauty. Each photon of auroral light carries within it this entire epic, making every display a condensed version of cosmic history. This storytelling aspect resonates deeply with human consciousness. We are creatures who understand the world through narratives, and the aurora provides one of the most compelling stories in all of natural science. It connects the familiar environment of Earth's surface to the alien realm of space, the immediate present to deep time, the visible world to invisible forces that govern planetary existence. The aurora also reveals Earth as a dynamic participant in solar system processes. While we often think of our planet as stable and unchanging on human timescales, auroral displays show it responding actively to changes in the solar wind. The magnetosphere expands and contracts like a living thing breathing, adjusting to the ever-changing conditions of space weather. This dynamic quality extends to Earth's magnetic field itself, generated by convection currents in the liquid outer core thousands of kilometers beneath our feet. These currents change over time, causing the magnetic field to shift and fluctuate. The magnetic poles wander across the surface, following paths that reflect complex fluid dynamics occurring deep within the planet. Occasionally, Earth's magnetic field undergoes dramatic reversals where north and south magnetic poles essentially trade places. These events, recorded in the magnetic orientation of ancient rocks, occur irregularly over geological time. During transition periods, the magnetic field weakens significantly, potentially allowing more cosmic radiation to reach the surface and creating unusual auroral displays at unexpected latitudes. Historical records provide glimpses of particularly intense auroral events from past centuries. The Carrington event of 1859 produced displays visible as far south as the Caribbean, while telegraph systems worldwide were disrupted by the induced electrical currents. If a similar event occurred today, the consequences would be far more severe given our dependence on electronic infrastructure. This practical dimension of aurora science has become increasingly important as technological civilization grows more vulnerable to space weather effects. The same beautiful displays that inspire wonder also serve as indicators of conditions that could affect everything from satellite communications to power grid stability. Modern aurora research thus serves dual purposes, satisfying scientific curiosity while helping protect technological systems from solar storm impacts. Ground-based camera networks now continuously monitor auroral activity across vast regions, creating unprecedented databases of display behavior. These automated systems can detect and track auroral movements, even when no human observers are present, revealing the intricate patterns and rhythms that govern these phenomena. Citizen science has also transformed aurora research, with enthusiasts around the world contributing observations and photographs through apps and websites. This global network of observers complements professional monitoring systems, often capturing unusual phenomena that might be missed by automated instruments. Some of the most spectacular auroral images in recent years have come from dedicated amateur photographers who spend countless hours in remote locations waiting for perfect conditions. Social media has created virtual communities of aurora watchers who share experiences across continents. During periods of high activity, these networks buzz with real-time reports and images, creating collective experiences among people who might never meet but are united by fascination with celestial lights. The democratization of aurora photography has also highlighted the importance of preserving dark skies. Light pollution can wash out all but the brightest displays, making these phenomena increasingly inaccessible from populated areas. The aurora has thus become a symbol of what we stand to lose if artificial lighting continues to spread without consideration for natural nighttime environments. As you settle deeper into relaxation tonight, consider how the aurora connects you to countless generations of humans who have looked up in wonder at these same lights. The Inuit watching from ice floes, Viking explorers navigating by their glow, medieval chroniclers recording unusual displays as portents, all witnessed the same fundamental phenomenon you might glimpse if you ventured to polar regions tonight. The aurora embodies continuity across vast spans of time. The same processes that paint today's polar skies with light have been operating for billions of years, since Earth first developed its magnetic field. They will continue long after our civilization has passed, a constant feature of planetary existence wherever worlds possess magnetic fields and atmospheres to illuminate. There's something profoundly peaceful about this perspective, the aurora as Earth's way of participating in cosmic processes that dwarf human timescales. While we experience these displays as brief moments of beauty, they represent the ongoing conversation between our planet and its star, mediated by invisible forces and conducted in the language of light. The particles creating tonight's aurora began their journey in nuclear reactions that might have occurred before human civilization existed. They crossed the vast emptiness between worlds, encountered Earth's magnetic embrace, and now end their cosmic voyage as photons entering your imagination. It's a journey that connects the nuclear furnace of the sun to the quiet moment of your contemplation, bridging scales of space and time that ordinary experience cannot encompass. Even the atoms that glow when struck by solar particles carry ancient stories. The oxygen that produces those familiar green curtains was forged in stellar cores billions of years ago, while the nitrogen contributing blue and purple hues was scattered by supernova explosions across galactic distances. Every auroral display is thus a reunion of cosmic elements, brought together by chance across unimaginable expanses of space and time. This perspective transforms the aurora from a mere atmospheric phenomenon into something far more profound, a visible reminder of our connection to the universe itself. The same carbon atoms in your body might once have been part of distant stars. The iron in your blood was created in stellar furnaces and distributed by cosmic violence. Tonight's aurora connects you directly to nuclear processes happening in the sun at this very moment. The aurora also reminds us that we live within the extended atmosphere of our star, constantly influenced by solar activity, despite the vast distance separating Earth from the Sunday. The magnetosphere that creates these beautiful displays also protects us from harmful radiation, maintaining the stable environment that allows life to flourish. We exist within a delicate balance of cosmic forces, shielded by invisible fields while remaining connected to stellar processes. As your thoughts grow quieter and your breathing deeper, let the aurora guide you toward dreams filled with dancing lights and cosmic connections. Imagine yourself floating among charged particles as they complete their epic journey from solar core to polar sky. Feel yourself becoming part of the ancient dialogue between stellar wind and planetary magnetism that has been creating auroral beauty for eons. Picture the moment when invisible energy becomes visible light, when particles that have traveled across the solar system finally encounter atmospheric atoms and release their energy as photons. Each collision creates a tiny flash that joins billions of others to paint those luminous veils across the darkness. You are witnessing the transformation of nuclear energy into beauty, the conversion of invisible forces into visible wonder. The aurora will continue its gentle performance throughout the night and into countless nights to come. Somewhere above Arctic tundra or Antarctic ice, curtains of light are swaying in cosmic winds, powered by fusion fires burning millions of miles away. It's a show that requires no audience but rewards any who take time to witness it. A celestial ballet choreographed by physics and performed with elements that compose our world. Even when clouds hide the stars or city lights wash out the sky, the aurora continues its ancient dance. Those charged particles still spiral down magnetic field lines, still collide with atmospheric gases, still release their energy as light that paints polar regions with colours that have no earthly names. The performance goes on whether we watch or not, a constant reminder that beauty exists everywhere in the universe, often in places and at scales we rarely consider. Tonight, as you rest beneath the same sky that hosts these magnificent displays, remember that you are part of this cosmic story. The elements in your body, the air you breathe, the planet that holds you all are connected to the same processes that create the aurora. You are literally composed of star matter, participating in a universe that expresses itself through countless phenomena, from galactic spirals to gentle glows above polar ice. The aurora awaits, patient and eternal, ready to paint darkness with its ethereal artistry whenever solar conditions align with planetary magnetism. It connects us to our sun, to the protective embrace of Earth's magnetic field, and to the long history of humans who have found wonder and meaning in lights that dance across polar skies. Sleep peacefully, knowing that somewhere in the night above, the aurora continues its timeless choreography, adding another page to the longest-running light show in the solar system. Let its gentle radiance carry you toward dreams where charged particles become shooting stars, where magnetic field lines transform into rivers of light, where the boundary between Earth and space dissolves into pure, luminous beauty. The aurora dances on through the darkness, a bridge between worlds, a messenger from our nearest star, a reminder that we live within a universe where the most fundamental forces of nature collaborate to create moments of transcendent beauty. It is always there, always dancing, always connecting us to the cosmic processes that make our existence possible, a gentle light in the darkness, a whispered promise that we are never truly alone in the vast and wonderful cosmos that is our home. The aurora has always been humanity's most accessible window into the invisible architecture of space itself. While we cannot see magnetic field lines or touch streams of charged particles, the aurora makes these abstract concepts tangible through the simple act of looking up. It transforms the intangible into beauty, the theoretical into wonder, the distant into something that feels almost close enough to reach. There's something particularly moving about how the aurora reveals the interconnectedness of everything. The same magnetic field that guides those dancing lights also deflects harmful cosmic radiation, creating the protective bubble within which all terrestrial life exists. We live inside this invisible shield, mostly unaware of the constant bombardment of particles that would strip away our atmosphere were it not for Earth's magnetic embrace. The aurora reminds us that protection and beauty often spring from the same source. The magnetosphere doesn't just guard us, it transforms potential destruction into spectacle, channeling what could be harmful into something sublime. It's a cosmic alchemy that turns the raw energy of stellar winds into the gentle glow that has inspired countless generations of stargazers. As space exploration advances and humans venture beyond Earth's protective magnetosphere, the aurora takes on new significance. It becomes not just a phenomenon to admire, but a reminder of what we leave behind when we journey into the void. Future Mars colonists will live beneath skies that never know the familiar green curtains of home, protected instead by artificial shields and underground habitats. Yet even on alien worlds, the physics that create Earth's aurora might manifest in different but equally wondrous ways. Mars, with its thin atmosphere and patchy magnetic fields, hosts its own faint auroral glows, diffuse and subtle, but real nonetheless. Other planets throughout the galaxy might paint their skies with colours we've never imagined, using atmospheric gases that don't exist on Earth to create displays of alien beauty. The search for life elsewhere in the universe might well be guided by the search for auroras. Strong magnetic fields that create vibrant light shows also provide the stable conditions necessary for life to emerge and evolve. When we finally detect the auroral glow of a distant exoplanet, we might also be seeing evidence of a world where life could flourish under the protection of its own magnetic embrace. But perhaps the most profound gift the aurora offers is its reminder that wonder requires no special equipment, no advanced degrees, no elaborate preparations. It asks only that we look up, that we allow ourselves to be present in the moment when charged particles complete their journey from the nuclear furnace of the sun to the thin air above our heads. It invites us to witness the universe expressing itself through the most fundamental of languages, light. The aurora connects us not just to cosmic processes, but to the deepest parts of ourselves that remain capable of awe. In a world increasingly dominated by artificial lights and digital screens, these natural displays of luminescence remind us of our place in a much larger story. They whisper that we are part of something ancient and ongoing, participants in cosmic conversations that began long before we existed and will continue long after we're gone. Tonight, as the solar wind carries its ancient cargo across the emptiness between worlds, as electrons spiral down invisible highways toward their appointment with atmospheric atoms, remember that you are witnessing more than a mere display of lights. You are seeing the visible signature of forces that shape the very conditions under which life itself could emerge on this pale blue dot we call home. The aurora has been Earth's constant companion since our planet first developed its magnetic personality billions of years ago. It danced above the primordial oceans when the first stirrings of life began in the depths. It painted the skies when dinosaurs roamed the continents, when ice ages came and went, when our earliest ancestors first looked up and wondered at the lights that moved without sound across the darkness. And it will continue long after our cities have crumbled to dust, long after the last human voice has fallen silent. The aurora is patient in the way that only cosmic phenomena can be patient, not indifferent, but simply operating on scales that dwarf our brief flicker of consciousness. It reminds us that beauty is woven into the very fabric of physical reality, emerging naturally wherever the right conditions converge. There's something deeply comforting about this permanence. While our individual lives are filled with uncertainty and change, the aurora provides a touchstone of continuity. The same physics that creates tonight's display govern the lights that danced above the ice during the last glacial period. The same gentle collision between solar particles and atmospheric gases will paint tomorrow's polar skies and the skies of 1,000 tomorrows beyond that. As you drift toward the threshold of sleep, let yourself imagine becoming one of those ancient photons that began its journey in the sun's core perhaps 1,000,000 years ago. Feel yourself slowly working your way outward through the dense solar interior, joining the solar wind, racing across the void at unimaginable speeds, only to end your cosmic odyssey as a single point of green light in an auroral curtain above some distant tundra. Your brief flash adds to a tapestry of light that has been continuously woven for eons, each thread a story of nuclear fusion and magnetic guidance, of planetary protection and cosmic connection. You are part of the aurora's eternal narrative now, a single note in the symphony of light that plays out night after night above the poles of our world. The aurora asks nothing of us except that we remain open to wonder. It doesn't demand our understanding, though understanding enriches the experience. It doesn't require our presence, though witnessing it can be transformative. It simply continues its ancient dance, a reminder that the universe is far stranger and more beautiful than our everyday experience suggests. In the end, perhaps that's the aurora's greatest gift, not the scientific insights it provides or the technological challenges it presents, but its quiet insistence that mystery and beauty are not opposites of knowledge, but its deepest companions. The more we learn about these dancing lights, the more remarkable they become, not less. So sleep now, knowing that somewhere above the curve of the earth, The aurora is painting the darkness with its ethereal brush. Sleep knowing that you are connected to this cosmic artistry through the very atoms in your body, through the air you breathe, through the planet that cradles you as it spins through space beneath its luminous crown. Sleep now, dear listener, with the gentle knowledge that somewhere in the darkness above, the aurora continues its timeless choreography. Let its ancient rhythm carry you toward dreams, where magnetic fields become visible rivers of light, where the boundary between Earth and space dissolves into pure, dancing radiance. The aurora has been our planet's most faithful companion, a constant reminder that we live not in isolation but as part of something infinitely larger and more wondrous than ourselves. It connects us to the nuclear heart of our sun, to the protective embrace of our magnetic field, and to the countless generations who have found solace and wonder in lights that paint the polar darkness with colours that have no earthly names. As your consciousness settles into that peaceful space between waking and sleeping, imagine yourself as part of this cosmic story. Feel the gentle pull of invisible forces, the slow dance of charged particles along magnetic highways, the moment when energy transforms into light in the thin air, hundreds of kilometers above your head. You are woven into this tapestry of light and magnetism, this endless conversation between star and planet that began billions of years ago and will continue long after the last aurora fades. Tomorrow, when you wake beneath the same sky that hosts these magnificent displays, you'll carry with you the quiet knowledge that beauty exists everywhere in the universe, often in places and at scales we rarely consider. The aurora reminds us that wonder is not a luxury but a fundamental part of what it means to be conscious beings in a cosmos that expresses itself through physics and poetry alike. Thank you for joining me on this gentle journey through the dancing lights of Earth's magnetic shield. If this exploration brought you peace, or simply satisfied your curiosity about the aurora, I'd be ever so grateful if you gave the video a like and perhaps subscribed for more sleepy science adventures. And do let me know in the comments where you're watching from. It's always wonderful to see how this little community of nighttime learners spans the globe. Until we meet again under the starlight, sleep peacefully, knowing that the aurora dances on, patient and eternal, painting the darkness with its ethereal artistry. The lights will be there tomorrow night, and the night after that, carrying on their ancient performance whether we're watching or not. A gentle reminder that we are never truly alone in this vast and wonderful cosmos we call home. Sweet dreams, fellow traveller of the night sky. May your rest be as peaceful as the aurora is beautiful, and may you always find wonder in the dancing lights that connect us all to the stars.